Continuing the same problem, finding the partial pressure of argon. So there's two choices of how I can do it from here. I can either take the moles of argon over my total moles times this total pressure I just found, and that'll give me the partial pressure of AR by taking the mole fraction and multiplying it by the total pressure. The other choice is I can do PV equals nRT, and instead of plugging in the total moles like I did before, I can take the moles of just argon and plug it in, and it'll give me the same answer. I'm going to go ahead and do this mole fraction way. So moles of argon was 0.25. The total moles was 2.42, and my total pressure was 15. So 0.25 divided by 2.42 times 15 gives me 1.55 ATM. For which gas would move the fastest, it's whichever one's the lightest. So the gas that'll move the fastest is H2. Which gas would move the slowest? It's going to be the one with the highest molecular weight of those, which will be AR. In a different container, oxygen has a speed of 300, and we want to find the velocity of argon. So this is a Graham's law question. Um, Rate 1 over rate 2 equals the square root of molecular weight 2 over molecular weight 1. So I want to make sure these guys are set up diagonal from each other. If oxygen has a speed of 300, it doesn't matter which one I choose as 1 and 2, but I prefer to solve for my unknown up here. It's just more convenient to have the unknown in the numerator. So if X is the speed of argon, I'm going to put argon's molecular weight there. And if oxygen speed, except I put AR instead of 40. If oxygen speed is 300, its molecular weight is going to go there and it's diatomic. So 32 divided by 40, square root of my answer times 300 gives me 268 meters per second. And now I want to check if oxygen's 300, argon is heavier, so it should be slower, and I got a slower velocity, so that makes sense. The last part of this question, if nitrogen effuses from a third container, blah, 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 how long does it take argon? Now we're given time. The time relationship for Graham's law doesn't set up diagonally, but sets up straight across. So once again, I want to have my unknown in the numerator. So if that is argon speed, that should be argon's molecular weight. And if 24 is nitrogen speed, I need to put nitrogen's molecular weight there. So square root of 40 over 28 times 24 gives me 28.7. And this is seconds for argon to take longer getting out of that container.